And just want to take a look at factoring differences of squares with fractions as an example. Imagine this situation. Let's review first what that means. When you have an expression that looks like a squared minus b squared, you can factor that into a minus b and then a plus b. So in our particular case, imagine the example has this shape right here. Let me grab a different color. So say it looks like 1/9 x squared minus 16. We have to identify the values of a and b. Now you have to be kind of careful here because it's not 1/9 because that's not showing a square. Remember, over here at step 1, the rule says you got to show a quantity squared. 1/9 doesn't show that. Often what that means is first you have to rewrite things a little bit. So in our case, you see where it says 1/9? I'm going to write that as 1/3 with a square up here, like that. And then times x squared and then minus 4 squared for now. Hopefully you know by basic laws of exponents that if you have 1/3 and it's squared and x is also squared, that can be further rewritten as 1/3 of x squared and then minus the 4 squared. And it's important to go through that whole process because now this right here is a and this other quantity right there is b. So I've identified the values of a and b. Once I have that done, I can just plug this into the pattern. So the pattern says that the answer basically will look like this. The answer will be this. You put parentheses down and you plug in. So it's going to be 1/3 x over here, another 1/3 x over here. Then for the first one, for example, you do like minus the value of b. In our case, as you can see, b is 4. And then also 1/3 x plus the value of b. So again, plus the value of 4. And let me just fix this. It's kind of not the best written there. So that's like x in that position. And that then is considered the answer, so to speak, right here. The factored form of the expression, answer. And that's it. Thanks so much for watching. Leave a like. I hope it's been helpful. I'll see you in another video.